Hi everyone. For this example, we'll take a look at an equation y equals 5x plus 1, and I want to find out the equation of a line that is parallel to this equation and passes through this point here, 2, 3. Alright, so the given information is this equation and this point, and we want to find out the equation of a line that passes through this point and is parallel to y equals 5x plus 1. Alright, so the symbol for parallel lines is this here. Alright, so what we want is to find the other equation. Alright, to do this, we want to take a look at the slope of the first equation, right? And we know that the slope is 5. And for the two lines to be parallel, the two slopes must be the same. So in that case, we can rewrite the formula, the slope-intercept formula, right? Which is y equals mx plus b. And we will replace the slope with 5, right? Because we want it to have the same slope. And since we know that it passes through the point 2, 3, we're going to replace the x and the y, so we can just say this is the x and this is the y, and replace the x and y with those numbers, right? So 3 will go here and the 2 will go here. Okay, so now we have one equation with one unknown, and the unknown is the b. Right, so if we do this out, we get 3 equals 10 plus b. And if we subtract 10 to both sides, right, so now b is just -7. Okay, so from all this, we have b is equal to -7, because 3 minus 10 is just -7. So once we know the b, we can actually plug it back into this slope-intercept form here. Okay, so now the equation will be y equals 5x plus the b that we found, which is plus a -7, or we can just simplify it to just -7. Okay, so let's highlight that here. So this equation represents the line that is parallel to this line here, which is represented by the first equation, and it passes through the point 2, 3. Okay, and we're done, and we're happy. Let's take a look at another example. We're going to start off with this equation here. Y is equal to 2x plus 3. Okay, and the point that is given is 2, 5. Alright, so this time I want to find the equation of a line that is perpendicular to this equation here and passes through the point 2, 5, or 2, 5. Alright, so the symbol for perpendicular lines is an upside down T. Okay, so when you see this, this implies perpendicular lines. So now we want to find the slope. Well, the slope of the original equation is 2. Alright, let's call that m1. And what we want to find is m2. Right? Well, if the two lines are perpendicular to each other, then m2 must be the opposite reciprocal of 2. So all you have to do is flip 2 over, so you get 1/2, and the opposite, just take the opposite sign. So in this case, it's going to be a -1/2. So the slope of the second line must be -1/2. Okay, so now we know the slope, and we also know that it passes through the point 2, 5. Okay, so again, we're going to start off by writing slope-intercept form, right? Y equals mx plus b, right? And the slope that we want to use is the -1/2, so let me replace that for m. right? So that's m2 here, negative 1/2. And the point that we want to use, so xy will be the 2, 5, right? So 5 will go here for the y, and the x will be 2, and everything else stays the same, plus the b, right? So now we have this one equation, and the only unknown is the b. Alright, so let's do it out. We get 5 on the left hand side, and we have a negative 1/2 times the 2, which is just negative 1, plus the b. So if you add 1 to both sides, you're going to get b is going to equal to 6. Okay, so b is equal to 6, and the slope is negative 1/2, so let's circle those information, right? We have these two important numbers here. The slope, which is negative 1/2, and the y-intercept, which is 6. So now we can write out the equation that we want. So let's make some space. We get y is equal to negative 1/2 x plus 6. Alright? So the relationship between the first equation that we have, which is this guy here, right? Y equals 2x plus 3. And this new equation that we found is that they are perpendicular to each other, and the second equation passes through the point 2, 5. Okay? So we're done here, and we're happy.